So we are doing prime factorization using factor trees. All right, and what's nice about factor trees is that there's actually more than one way to do it. What I mean by that is obviously there's multiple numbers that give you a composite number. So just because you do it one way doesn't mean that the friend beside you doing it a different way is wrong. There's just more than one way to do it. But you start with a composite number. Remember, a composite number is a number that has more than two factors. And you're trying to break it down until you get it all the way to prime numbers. Okay, so we're starting with 24, so prime factorization of 24. So here are my branches, because remember it's a factor tree. All right, so first thing you want to think of is what are two numbers that I can multiply together to give me 24. You don't want to start with 1 because remember prime is not, 1 is not prime, it's neither. So you were trying to break it down into prime numbers. All right, so what's something that gives me 24? Well, the first thing that comes to my mind is 4 and 6. Okay, and so from there you ask yourself, are either one of these numbers prime? And the answer is no. I can break those down again. So I'm going to draw branches from both of these numbers. Sometimes the branches really confuse students, so it's important that you understand what's happening here. You have to break down each number, so each number needs branches. So now you ask yourself, okay, well, what gives me 4? What times gives me 4? So 2 times 2 gives me 4. All right, well, what gives me 6? And that would be 2 times 3. Now, it's important that you keep your branches separated. A lot of students have issues with that spacing, but you don't want things to get too bunched up because it'll get really confusing. So now I've broken these down and I ask myself, okay, are any of these numbers prime? Well, luckily they are. And once they're prime, I like to circle them so that I know that I'm done. And I can clearly see, okay, there's nothing else to break down. So I can see everything down here is prime. Now let me just double check that these numbers that I've circled actually do give me 24. So 2 times 2, 4. 4 times 2 is 8, and then 8 times 3 does give me 24. So I did do it correctly. Now the way you're probably going to see it written as an answer is they're going to do it with exponents. So remember, how many 2's do I have? Well, it's 2 to the third power because I have 3 of them, and then times that 3 that's left over. Or you could see it written out the long way, so 2 times 2 times 2 times 3. All I did was rewrite those numbers up there with just putting a multiplication sign in between them. Because remember, you're trying to get back to that original number up here, but you want these numbers down here to be prime. All right, so let me go back to what I was saying with you can actually do it more than one way. So if we start with 24 again, well, somebody else in the room might say that they want to start with 2 and 12. So if I start with 2 and 12, okay, so remember 2 times 12 gives me 24. All right, and my first step was to ask, is either one of these prime? Okay, well 2 is prime, so I can go and circle that one. I'm already done with this branch. Okay, so now I just need to worry about this one right here. 12 is not prime. I can break 12 down. Okay, now once again, there's more than one thing that 12 can be broken down into, but it's not going to matter because you can do it either way. First thing that comes to my mind with 12 is 3 and 4. If you pick 2 and 6, that's totally fine as well. Okay, so there are my branches. Remember, every time you break something down, you got to ask yourself, is either one of these prime? So are 3 or 4 prime? And luckily 3 is prime, so I can be done with that one. Remember, once you circle it, you're done with it. Move on. 4 is not prime, so I can break down 4 again. Well, what times what gives me 4? Well, that would be 2 and 2. And remember, 2 is prime, so I can circle it. I'm done with it. Okay, so now that I can see everything's circled, nothing else can be broken down. And if you'll notice, it's the exact same as over here. How many 2's do I have? I have 1, 2, 3. So 2 to the third power, and then I have that 1, 3 left over. Okay, let's look at another one. Bigger number doesn't change anything. You do it the same way. Prime factorization of 144. Okay, so let's think about it. 144. It's definitely not prime, so let's break it down. Once again, many things you can start off with. I usually tend to go with what I think students are going to do the most, and so I think most students are going to pick 12 and 12. Okay, So I've broken it down. Next I ask myself, are either one of these prime? 12 is not prime, so I need to break it down again. Go and draw my branches from both of them. Okay, well, it gives me 12. Well, once again, you can do 3 and 4, you can do 2 and 6. It's not going to matter, you're going to get the same answer. So if I pick 3 and 4, and obviously this is the same because 3 times 4 gives me 12. Okay, are either one of these numbers prime? 3 is prime, so I'm going to circle it. So I'm done with this branch. Okay, 4 is not prime. Okay, so it can be broken down. That would be 2 and 2. Okay, 2 is prime, so I'm going to circle it. I'm done. This whole branch over here is done. Everything's circled. There's nothing else to be broken down. Because think about it. If you break down 2, I'm going to break it down to 1 and 2, and that doesn't really help me any. Okay, so once I come back over here to this branch, well, we said 3 is prime, so I'm going to circle it. Break down 4 to 2 and 2, and once again those are prime. Okay, so just go back and double check that you don't have any branches that are left. Everything's been ended with a circle. All right, and let's see, I've got 1, 2, 3, 4 2's, so 2 to the 4th power times 1, 2, I've got 2 3's. And let's just double check to make sure what we have actually does give me 144. Well, if I have 3 times 2, that's 6. 6 times 2 is 12. So this whole side over here gives me 12. 3 times 2 is 6. 6 times 2 is 12. So this whole side's 12. This whole side's 12. I know that 12 times 12 does give me 144. All right. Last one. Prime factorization of 96. Okay. So 96, composite number, which means I can break it down. So 96, it's even, so I know 2 has to work. So 2 and 48. All right, either one of these prime, and yes, 2 is prime, which means I can break down 48. All right, well, what gives me 48? Well, the first thing that comes to my mind is 4 and 12. Okay, once again, you could have picked something else. You're still going to get the same answer. Remember, don't pick ones. Steer clear of those. 4 and 12, are either one of those prime? No, they're not, which means I can break them down more. Well, what gives me 4? That would be 2 times 2. And I know that 2 is prime, so I'm going to circle it. Okay, what gives me 12? All right, well, that would be 2 and 6. Are either one of these prime? Yes, 2 is prime. 6 is not prime, so I need to break it down some more. Okay, well, what gives me 6? That would be 2 and 3. Everything is circled, everything's been broken down. I don't have any branches that are left, so I know that I must be done. All right, be careful with this one because there's a lot of 2's, so make sure you have them all. So this one way up here, 1, 2, 3, 4, 5. So 2 to the 5th power times this 1, 3 that's left. Now let's just double check to make sure it actually gives me 96. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. And then 32 times 3 is 96, so we did that correctly. There's not exactly a right or wrong way to write it like this. I usually do it in numerical order, so like I like to start with the smaller numbers and work my way up. But just be careful because it's multiple choice. They could have it listed in different ways. Just make sure that whatever it is does equal the number that you started off with.